I'm Rossano. I present multi-layer hierarchical SDN Packet-Optical restoration using P4 and Gnmi. Our solution uses one P4 switch to generate traffic for the experiment. So, this one here sends 73 gigabits per second in two different ports that goes all the way to the second P4 switch. This emulates traffic coming from two different tenants, a premium client and a regular client. The second P4 switch implements a slicer which directs traffic to the different network slices. A premium network slice carries traffic for premium clients, and a regular network slice carries traffic for regular clients. The orange link is used by premium clients, whereas the yellow link is used by regular clients. The yellow link is used as a soft protection link for the premium clients when the orange link is down. We've used 4 different boxes or hosts to conduct the experiments. An OTN emulator keeps turning one of the lasers on and off every few seconds. This makes the system detect a link up or down, which in turn fires all the reconfigurations we are going to show in the demo. This is the experiment initial state. P4 slicer outputs premium traffic at 73 gigabits per second. Regular client's traffic uses 40 gigabits per second. Then, the OTN emulator turns one of the lasers in the premium working path off. Now ONOS and all the transceivers in the premium working path perceives the link as down. The soft protection fast response in coordination with ONOS reconfigures the P4 slice to divert premium traffic to the soft protection link. At the same time, regular traffic is shaped to 20 gigabits per second, allowing a total combined output of 93 gigabits per second. After a while, the OTN emulator turns the laser back on again. Now the soft protection fast response agent coordinates with ONOS again, now to revert the P4 slicer to the original configuration. This whole cycle repeats every 30 seconds. ONOS sees the PADTech SPVL and one of the two P4 switches that runs Stratum. So here you can see the PADTech device using netconf, and here you can see the P4 switch. It runs Stratum, P4 runtime, Gnmi and Gnoi. Here is the ONOS optical UI, and here is the 8 PADTech SPVL optical ports being inquired using netconf. This screen shows all the optical ports parameters such as current input power and current output power. This interface shows the OTN emulator, a dashboard in Grafana displaying ports, status, throughput. Also it can be seen the soft protection fast response agent reacting to ports going up and down. It's possible to see port 7 and 3 changing its power from a value that represents down to a value that represents up. As can be seen on the emulation going from off, down to on, up. Now you can see it went off, down again. It happens every 30 seconds. And observing ports input and the output power, it can be seen that port 7 input power goes from minus 14 dBm to minus 35 dBm, and port 3 output power to minus 40 dBm. Now the laser is off, and you can see this yellow line representing port down, blue line going up indicating the response time. Here you have a better view of lines yellow and blue. Also you see RX1 going from 73 gigabits per second to 0, and RX3 stops receiving 40 gigabits per second and starts receiving 93 gigabits per second. Now you can see the laser is on again, fast response acts, and everything is back to normal again. Now let me show the application running on ONOS. Here they are. One that deals with fast response and the network slice one. Now let's investigate some of the tables used on the P4 program running on the Tofino. So here are the tables, M and IPv4 host. M is used to select a meter that configures the bit rate, and IPv4 host specifies the traffic output port. And you can see values changing and the experiment is running so that it generates the behavior we've seen before. Now let's go back to the dashboard again and appreciate it running. Now let's observe the tables again. You can see here the number of matches. Now let me change the emulation interval from 30 to 10 seconds and let's observe the results, and then I'm going to change it to 15 seconds and let's observe the results. And that's it. That's our demo. Thank you so much for watching it.